Hello viewers, so for this video, I'm going to discuss some basic functions of PLC. This includes set and reset function, relay function, and internal relay functions of PLC. So let's discuss the initial program first that we see in the screen. Okay, so for this basic program, when we toggle the toggle switch, it will remain on, and when we want to turn off the light or the light bulb, we need to press it again to untoggle it. Okay. But sometimes, toggle switch is not safe to use in operation. Uh, the other option for us to use is the push button. Okay. So I'm going to set up push button program. Okay. So I'm going to change the second toggle switch into push button. Okay. And then the second light bulb will be turned on. So if I push the momentary push button, the green one, the light bulb number 2 will be on. But when I unpress it, it will be off. Okay. So what are we going to do in order for us to make the operation similar to the usage of toggle switch? So what I mean to say is when you press the push button, you can unpress it and it will remain on. And you need to press again a push button in order for it to be turned off. Okay. So for that, we're going to use the set and reset function. So how do we configure it to have a set and reset function? First, again, press the out, this one, and then the action. Instead of out, copy to out, we are going to select set retentive set. Okay. So let's observe what's going to happen. When I press the push button, the light bulb remains on. Even if I unpress it, it still remains off. It still remains on, sorry. Okay. So right now, in our program, there is no way for us to turn it off. Okay. So even if you put a normally closed contact and press the button for that, this will not be turned off. Okay, so how can we turn off the output that is energized using a set function? So I'm going to remove this first. So for that, we need additional push button. So I'm going to select I0.2. And then for the output, we're going to choose the RST or retentive reset. This one. Okay. And then we're going to use the address same with the address we used for the set function. So that is I0.1. So we're going to use I0.1 also. So how can we turn it off? I'm just going to change it to push button again. So in order to turn off the output that is turned on by the set function, we need to have a reset function. Okay. So I turn it on using the set and I turn it off using the reset. Okay. So now this is similar to the function of the first program or this first rung. Okay. So you can press it or you can toggle it. You can leave the area and when you return, you can turn it off again. Now for the second program, the same. You can press it, you can leave the area, and when you return, you can turn it off again. Okay? And there is another ways so that you can create a similar program from what I have shown. And that is when we use the latching circuit or the latching program. So for that, we're going to use the relay function. So how do we do that? First, I'm going to create another program. And I'm going to use the button that I have not used so far. So I0.3. And I'm going to create an output using an Q0.3. Now again, if I press the push button, it will be on, but when I unpress it, it will be turned off. Okay. So how do we retain its on position? So remember this is Q0.3 for our output. We can use it as an input. Okay. Q0.3. Okay, so I'm not going to connect it yet, but observe this output or this input, the sal 0.3 or the address is Q0.3 in the input. So when I press I0.3, our output, this output will be energized, and look at the sal 0.3, it is also energized. Okay, so that is the relay functions for the output. So imagine this is a coil, and when a coil is energized, its external contact or its contact will change its status. This is normally open, so it will be closed once the coil or the output is energized. Okay. So again, please observe, when I press it, it is energized. Now, how do we use this to retain its on position? So we'll just to make it connected in parallel to our push button. Okay. So when I press the push button, so observe that when I unpress it, our output or our light bulb is remained open or remained energized. Okay. But in order to turn off this one, we need to use another push button. So I'm going to use I0.4. Okay. So for me to turn it off, I'm going to press the I0.4. Again, to turn it on, I use I0.3 with the use of our relay function that is configured to perform latching function. So we use the out or the Q0.3 for the output, and the address for the input is Q0.3 also. Okay, this is for the set and reset and relay function. Now for the internal relay, okay, let's have a condition first. A special light bulb, so this is the title. In order to turn it on, in order to turn on the special light bulb, condition must be satisfied. So first that we need to satisfy is push button A and B must be pressed at the same time. Once you press it, you can unpress it. Okay. Number 2, any or both of the push button C or D must be pressed. Okay. So we have we have 4 push button, and we have 2 conditions that must be satisfied. Let's try to create a program for this one. Okay. So it says that we need to have push button A and push button B to be pressed at the same time. Sorry. So for me to be able to press it easily, I'm going to use push button that is far from each other. Okay. So the first one is I use I0.0. So for now, I'm going to use I0.3. So for the first condition, in order for me to turn on the special light bulb, both push button A and B must be pressed at the same time. And once pressed, you can unpress it. So I'm going to push it at the same time. Okay, so this is not the first bulb is not the special button or the special bulb. Let's just say the Q0.7, this last part, is our special bulb. Okay. So I'm just using this first output as part of the process. Okay. So again, when I turn it on, or when I press the A and B button, Okay, this is the first condition. But according to the condition, you can unpress it and it is enough for our program to be satisfied. Okay. So we're going to use the relay functions that I have recently demonstrated. Okay, so I set a latching for this one. So when I press both the button and I unpress it, I can leave it as it is. Okay. So another condition is that any or both of the push button C or D must be pressed. Okay. So another set of push button for this one. So I'm going to use I0.1 parallel to push button I0.4. And I'm going to use Q0.2 for now. Okay, so if any of this push button is pressed, the Q0.2 will be energized. So I'm going to try it. Okay, I press the I0.1, it is turned on. I'll press the I0.4, it is turned on also. But the problem is when I unpress it, it will be turned off. So for us to retain its energized position, again, we're going to latch it. Okay, so we're going to use the same address, the Q0.2. Okay. So if I press I0.1, it will be turned on. But the problem is I cannot try the I0.4 because there is no way that I can turn it. I can turn off this bulb. So in order for me to turn it off, I'm going to add a turn off push button. Okay, so I'm going to use I0.7. And for this one, I'm going to use the same I0.7. So that when I press the push button, both the program will be turned off. Okay. So observe that I have placed the turn off push button near the output. Oh, sorry. Okay, near the output. And then the second turn off button is placed near the input side. So there is no issue for this one. So you can place it anywhere as long as it is before the output uh, coil. Okay, so this is the output coil. So you can place it here, you can place it here, no problem. Okay. So now let's go back to the condition. In order to turn it on, the special light bulb, the conditions must be satisfied. So push button A and B must be pressed at the same time, and any of the push button C must be pressed. Okay. So for that, I'm going to use this address again, the Q0.0 and Q0.2. Okay. And I'm going to use the relay function. Okay. So Q0.0 and this is for Q0.2. And I'm going to use the Q0.7. So the special bulb is the last part. Okay. Maybe we change it. We change the color. So I'm going to use green light. Okay. So let's try if it satisfies the condition. So first I'm going to satisfy the condition 1. Okay. It remains on the Q0.0 and then the condition 2. I'm going to press I0.4. Okay, it also remains on. And then we see that the special light bulb is energized. Okay, let's try it again, but I'm going to satisfy the second condition first. Okay, so I turned on the second bulb, and then I'm going to satisfy the first condition. Okay, so regardless if I satisfy the second one first and then the first one, there is no issue with this program. Okay, now from the condition, we just need to turn on a special light bulb. Okay, but for this program, I turn on a special light bulb, but I also turn on two ordinary light bulb. Okay, so for practicality, this is not a good program because we just need to energize one light bulb, but we are using two terminals for our output. Okay, so the first terminal is for the first bulb, and the second terminal is for the second bulb. So we are wasting that terminal for a not important purpose. Okay, so what I want to say is that we can create a program that we are going to use only one output terminal. We're just going to need, we just need to turn on the Q0.7, and we're not going to turn on any other output terminal. Okay. So how do we do that? We're going to use an internal relay function. So we can satisfy the condition from our sample without using Q0.0 and Q0.1. So how do we do that? Again, we're going to use the internal relay functions. So how do we select that? Instead of Q, we're going to use the M. Okay, imagine or observe, instead of SAL, you can see that it is RAM. Okay. So again, I'm going to return it to Q. This is what it looks like when we use the Q, and when we use the M, it is out RAM 00. Okay. So we're just going to change it to M. And for this one, we're just going to use the M also. Okay. And for this one, again, set it as M. And the latch, we're going to set as M also. Wait, before I do that, I think I need to turn off the because it is turned on yet. It is still turned on, sorry. So I'm going to turn it off first. So please remember, before you change the program, make sure you reset it first. And so Q0.0 and Q0.2 is turned off. Now I can set it to internal relay. So what I need to do is all the Q0.0 and Q0.2 must be changed into M0.0 and M0.2. Yan. So please observe. So when I press, or when I satisfy the first condition, I press the first and second push button. Okay. So no light bulb is turned on the output side. Okay. But if you see, this RAM and this RAM for the input and RAM for the output is energized. Okay. So let's try to energize the RAM for the second rung, the RAM 0.2 for the output, and RAM 0.2 for the input in the latching area. Okay. I'm going to press I0.1. Okay. So again, no light bulb is turned on, but look at the Q0.7. It is now turned on. Okay. So this is the internal relay function of the PLC. Okay. So instead of wasting an output terminal just to turn on a specific bulb, I use the internal relay function, so that we can save 2 light bulb or 2 output terminal for any other important output device that we need to energize or to be energized. Okay, so I hope you understand this demonstration. So if you have question, feel free to comment. So again, I'm going to repeat the simulation. So I'm going to turn off to energize the first, or to satisfy the second condition first. So this one, it is now energized. The relay is energized, and then I'm going to energize the first condition. Okay, and then the light bulb, the special light bulb is turned on. Okay, thank you very much for watching this video.